coolin' for the weekend. Drop the top and then we out. We do this every season. Sunshades on a sunny day. Doing 80 and we switching lanes. Just keep it cool and chillin' with the babe. Don't call my phone, I hear what you say. Oh, what you say. We ain't gotta keep this on the low. Don't do it fast, we can take it slow. Show you things that you ain't seen before. Before you go, you ought to know. I won't be catching.
Hey guys, what's up? It's your boy Trix. Today we're going to be doing some more Rust Rogue. We're going to be doing rooms and dungeons. So hopefully that just opens up. There we are. I'm just going to have my BRB screen ready just in case I need it. I'm still coughing a bit, so if you hear me coughing, that's probably why. I do have a water bottle next to me though. Let me just grab that. There we are. There's my water bottle. So if I go into Rust Rogue, I think it's this one? No. I should have just trusted the IntelliSense. Give it that sec. I'm very used to the normal Git branch names with like fix, hotfix, bug, stuff like that. So I just keep doing like x/whatever. Anyway, if I open up VI, just let that load. So let me just move over a bit. There we are. So a popular method of map generation uses binary space partition to subdivide your map into rectangles of varying size and then link the resulting rooms together into corridors. You can go a long way with this method. NetHack uses it extensively. Dungeon Crawl, Stone Soup uses it sometimes, and my project One Night in the Dungeon uses it for CO levels. This chapter will use the visualizer from the previous chapter to walk you through using this technique. Implementing a new map, subdivided BSP, the boilerplate. We'll start by making a new file in map builders. So if I open up file tree, src, map builders, A4, BSP dungeons.rs. We start by making the basic BSP dungeon builder struct. So let me just copy this. Oh yeah, by the way, I'm currently watching a new anime which I was like, oh, I haven't read this in so long. It's called Mashal, and if you haven't read it, I recommend reading it. It's kind of like Harry Potter, but if Harry wasn't like super OP at magic, but was like insanely strong. So like in the first episode of the anime, there's like a fight scene, right? Which is like very common for anime. But it's like, this dude goes on like a monologue of, oh yeah, he's gonna fire like the most powerful fireball or whatever, like magic spell at this kid, and there's no way this kid can block it, and then the kid just smacks it out of the air, and the dude just makes like the most defeated face possible, and I was just ducking, and I was like, oh, I remember this. I started reading the manga again, and I was like, oh, the memories is so good. Oh, I'm actually crying thinking about it. But yeah, I do genuinely recommend you when you watch it. If you like just want a quick laugh, go for it. It's not like it's not like the humor in my eyes are burning for some reason. It's not like the humor in what's it called? Grand Blue, which is like dirty jokes, right? It's more like what's it called? Like that, the type of humor that just makes you think, oh, what the hell? Like he'll just do something and then you're just gobsmacked, and then the characters are like, that's not possible, and you're like, that's not possible either, but he just does it anyway. It's like shock humor, yeah, not like bad shock humor, but just like you wouldn't think the character would do that, but they do it anyway. It's very funny. I think my mum might be cooking or something. Anyway, Yeah, that was my mini chat about manga. Hang on one sec, I'm just gonna wash my eyes. BRB.
We ain't gotta keep this on the low. Don't do it fast, we can take it slow. Show you things that you ain't seen before. Before you go, you ought to know. I won't be catching feelings. But she got me catching feelings. I hate to catching feelings. But she got me catching feelings.
Sorry about that. We'll see how it goes, but I might need to do that again because my eyes are just burning a bit. Don't know why. This is basically the same as one of those, as the one from Simple Map Builder, and we've kept the rooms vector because this method uses a concept of rooms as well. We've added a rect vector. The algorithm uses this a lot, so it's helpful to make it available throughout the implementation. We'll see why it's needed shortly. Now we need to implement map builder trait to the type. So if I copy this, that's gonna take a while, but then this is all pretty much the same as Simple Map Builder, but build map has a comment reminding us to write some code. If you ran the generator right now, you get solid blubber walls and no content whatsoever. We also need to implement a constructor of BSP map builder. Once again, it's basically the same as Simple Map Builder. So implement for I'll just chuck this underneath it. Lastly, we'll open map builders mod.rows and change the random builder function to always return our new map type. Okay. So if I go to here, BGP, there we are. Once again, this isn't in the slightest bit random, but it's far easier to develop a feature. Am I using this anyway? Hang on, let me just undo. Oh, fudge. Give me a sec, I just realized what I need to do. I need to take this, VGP, then I need to go to line 3, then let me just change this to BSP dungeons, then v dollar change BSP dungeons colon BSP dungeon builder. There we are. We'll worry about swapping on map types later. On to making the map. Note that this implementation pulled from the C++ One Night in the Dungeon. We'll start with the room generation. Inside our implementation, we'll add a new function. So inside we'll add a new function. So this is inside the, so if I copy this, there should be down here. There we are. And then VG just up, and then I want to shift one over. There we are. What on earth does this do? We clear the rect structure we create as part of the builder. This will be used to store rectangles derived from the overall map. We create the first room, which is really the whole map. We've trimmed a bit to add some padding to the sides of the map. We call add subrecs, passing it the rectangle list and the first room. We'll implement that in a minute. But what it does is it divides the rectangle into 4 quadrants, and each of the quadrants and adds each of the quadrants to the rectangle list. Now we set up a room counter so we don't infinitely loop. While the counter is less than 240, a relatively arbitrary limit that gives fun results. We call get random rect to retrieve a random rectangle from the rectangles list. We call get random subrect using this rectangle as an outer boundary. It creates a random room from 3 to 10 tiles in size on each axis somewhere within the parent rectangle. We ask, is it possible if the candidate can be drawn to the map? Every tile must be within the map boundaries and not already in a room. If it is possible, we mark it on the map, we add it to the rooms list, we call add subrect to subdivide the rectangle we just used, not the candidate. There's quite a few support functions in play here, so let's go through them. So I'm assuming this also, god damn it, this also goes here, and then v colon, hang on, so v, then colon 24, no, so v, let's say 10k, shift this way, there we go. I was trying to be lazy by just specifying the line number, but then I was like, shit. I really want to turn on relative line numbers. Relative line numbers. Oh, I know I searched this up a while ago and I was like, oh, I'll do this off stream, and I didn't even bother. Force relative numbers. I want to enable it. I want to force it. Give me relative numbers. Colon verbose set relative number. Oh, that's so nice. I just want to check. Does it persist? Ah. Let's do config? No. There must be a way to go to the config directory. I know where it is, hang on. RN. Enable. Okay, let's try. Set. No, no, that's not what I want. Colon set. What? Just Oh, for God's sake. Chizzy. Set. Alright. Yeet. There we are. VI. If you want to, no. Forward. Orange. Yeah. Relative. Number. How do I name it in NV chat? Huh? Relative should be somewhere. Relative. Okay, let's have a look. That is there. Needle iron. Those mappings. No. I'm looking for default. No. Init. No. Options. Numbers. Ah, that's so much nicer. It was like, I was just wondering, would that do it? And then it done it. So I'm just happy now. Never have to think about what number to jump to ever again. The function as subtracts is core to the BSP binary space operation. It takes a rectangle and divides the width and height in half. It then creates 4 new rectangles, one for each quadrant of the original. These are the rect list graphically. Next up is get random rect. So in here, I need to do get random rect. There we are. V4J. Shift that way. Oh, that's so much better. I never have to think about it ever again. I said it already, but I never have to think about it ever again. It's so nice. Returns the first one, otherwise it rolls a dice for 1d size of Rex list and returns a rectangle found at the random index. Next up is get random subrect. Okay. So P, then BG, that way. There we are. So this takes a rectangle as a parameter and makes a mutable copy to use as a result. It calculates the width and height of the rectangle and then produces a random width and height inside the rectangle, but no less than 3 tiles in size. and no more than 10 of each dimension. You can tweak those numbers to change your desired room size. It then shunts the rectangle a bit to provide some random placement, otherwise it would always be against the side of the sub-rectangle. Finally, it returns the result graphically. Finally is possible. Jeez, that's a lot of functions. Oh god. Oops. This way. There we go. This is a little more complicated here, but makes sense when you break it down. Takes a rectangle as a target representing the room we are looking at. Creates a mutable copy of the rectangle called expanded. We then expand the rectangle out by 2 tiles in each direction to prevent rooms from overlapping. We iterate every x and y coordinate in the rectangle. If x or y are out of the map boundaries, we mark the can build as false. This won't work. If we still can build it, we look at the existing map. If it isn't a solid wall, then we overlap the existing room and mark that as can't build. We return the result of can build. So now that we've implemented all of these, the overall algorithm is more obvious. We start with a rectangle covering the entire map. We subdivide it, so now our map has 5 rectangles, 1 for each quadrant and 1 for the map as a whole. We use a counter to ensure that we don't loop forever. We'll reject a lot of rooms while we can still add rooms. We obtain a random rectangle from the rectangle list. Initially, this will be one of the quadrants or the whole map. This list will keep growing as we add subdivisions. We generate a random sub-rectangle inside this rectangle. We look to see if there's possible room. If it is, we apply the room to the map, build it, add it to the rooms list, subdivide the new rectangle into quadrants and add those to our rectangles list. Store a snapshot of the visualizer. This tends to give a nice spread of rooms, and they are generated not to overlap. Very NetHack-like. Okay. You can cargo around now. You can see rooms with no exits. You'll get to watch rooms appear around the map in the visualizer. That's a great start. That's interesting. Okay, so I'm going to cargo run for now, just so I can fix any like import issues and stuff, just because I know it's a pain with my current setup. I don't know why it doesn't auto import. Probably because I'm copying it over instead of typing it out, but then that's still weird that it won't auto import. Unless there's an option to do it on copy. Ooh, I just remembered that I've done that now. I might want to do that for my work config. Ah, shit. Okay. What's it complaining about? Okay, so spawner is unclear crate. Okay, use unclear crate. I know what I can do, and it's going to be a very okay. So dollar yank. Okay. That's why I was like, oh yeah, I know what I can do. I just nicked it from the other one because I was like, if it's the pretty much the same implementation, it's probably going to use the same imports, right? Just need this to load. Interesting. You don't have to do this, but this helps me. Sort by takes a closure that is an inline function. That's not how it is. I suppose. Oh yeah, lambdas in Rust are, I want to say nice. Kind of. So like this is okay. This is the like this in Java. This is the object. This is like a method on that object. it'll be better if I say that this is like a stream on an object, because in streams most of the time do take a lambda. Then this is where you define your lambda, which is the parentheses of a lambda. So like normally you'd have a parentheses to an arrow and then squiggly brackets, right? This would be your parentheses. Then this is the operation you want to perform on it. That's all. It looks nice, but if you don't know like what it, if you don't know the syntax, then it's painful. But if you don't know the syntax in any language, but I was gonna say if you don't know the syntax in other languages, it will be the same. But other languages do it kind of like Java, but they just don't need the enclosing curly braces most of the time. I know in JavaScript you need them. In Flutter you need them. So like in the Java mimic languages, I want to say, yeah, in the Java mimic languages you can have lambdas like that, but I don't know what a lambda looks like in Python. I think it's just a equals. I think it, what, lambda expression in Python. It's been a while since I've done Python, so Python lambdas. What does it look like in Python? You have to type in lambda. That's pain. For all Python developers out there, I feel so bad for you. That's so long. Why? If you know it's going to be a lambda, just let you use the normal syntax where you just put like a bracket, arrow, and then whatever you want it to do. Why do you have to define lambda, do this? Because like the syntax, other than saying lambda in front of it, the syntax is basically the same anyway. It's anyway. I'm just gonna open this in a new tab so I can copy over everything that I need to edit. So in, okay, let's go into SLC. Map builders. Let's do a VI. SLC, map builders, BSP. Okay. So in here, I just need to grab all of this. PHP. There we are. Mod. Oops. There we are. PHP. If it builds fine, then I'm going to just take it. Oh, whoops. This is supposed to be dungeon. BSP dungeon.rs. I believe it's there. Oh, god damn it, rest. Up. There we go. That should be fine now. If I cargo run, I think it should work. I say that, but there might be some code changes in main. No, it looks alright. It looks a lot nicer as well. I'm gonna die. Damn. It does look a lot nicer though with the map generation. Because now you don't have like random rooms that will just spawn on top of each other. Like before you might have like a room spawn here and then a room with like its corner spawn right on top, making the room like kinda awkward going through. But yeah, that's nice. Cool, I'm just going to commit this changes. If my browser doesn't break. Okay, so I wrote cargo instead of git. Git commit. Just waiting for the git window. There we are. Trap 25. BSP room dungeons. Whoops. Next chapter, chapter 26, which is BSP interior design. When it loads up, there we are. There we are. Anyway, thanks for watching. Like, subscribe, enjoy the rest of your day, and peace.